In this lesson, we are going to talk about a very important property of derivatives, which is called a chain rule. What exactly chain rule says? If you have a function f of x, which is equal to another function which is a composite function, let's say g of x, in terms of another function h of x, then to find the derivative of f, just take the derivative of outer function, which is g, in terms of the interior function, which is h of x, and then multiply it by the derivative of the interior function. It may look a little bit confusing and complicated, but when you see how this property is being used to find the derivative of composite functions, you can appreciate the power that this technique has. Our first example is to find the derivative of f of x if f of x is 3x minus 5 exponent 4. To find the derivative here, let's say we introduce a function g of x to be x exponent 4. And we also define h of x to be 3x minus 5. Then I can write f of x, which is given here, as f of x is equal to g of h of x. Remember, g of x is x exponent 4, h of x is 3x minus 5, so g of h of x is the same as 3x minus 5 exponent 4, which is the same as before. Now, using the chain rule, f prime of x is equal to g prime of h of x times h prime of x. But g prime is going to be 4x cubed. But it's g prime of h of x. h of x is this one, so I replace x with 3x minus 5. So I'm going to get 4 3x minus 5 exponent 3, and then h prime of x. h prime of x is the derivative of 3x minus 5, which is just 3. So the answer is going to be 12 times 3x minus 5 exponent 3. The next example is to find the derivative of f of x is equal to square root of 4 minus x squared. So again, we are going to say, let's say g of x is square root of x and h of x is 4 minus x squared. So f of x is really g of h of x. So f prime of x is equal to h prime of h of x times h prime of x. Now, g prime is going to be the derivative of g of x, which is here. Remember that g of x is square root of x, which is x exponent 1 over 2. So g prime of x is going to be 1 over 2 exponent. 1 over 2 minus 1 is negative 1 over 2, which is 1 over 2 square root of x. But remember, g of g prime has to be evaluated at h of x. h of x is this one. So f prime becomes g of x evaluated at 4 minus x squared. So it's going to be this one times h prime of x. h prime, this is h of x. h prime of x is going to be negative 2x. So the answer 2 is going to be cancelled with 2. So the answer is negative x over square root of 4 minus x squared. There is another notation for the chain rule, which is given here. It says that if y is a function of u and u is a function of x, then the derivative of y with respect to x is going to be the same as the derivative of y with respect to u and the derivative of u with respect to x. The next example says that if y is negative square root of u and u is 4x cubed minus 3x squared plus 1, determine dy over dx. So we are going to use the second form of chain rule and write this one as dy over dx is the same as dy over du times du over dx. We know that y is negative u exponent 1 over 2, so dy to du is negative 1 over 2 u exponent 1 over 2 minus 1 is negative 1 over 2, which is negative 1 over square root of u. Then we have to find du to dx. We know that u is 4x cubed minus 3x squared plus 1, so du to dx is going to be 3 times 4 is 12x squared minus 3 times 2 is 6x, and the derivative of 1 is 0. So this is the derivative of u with respect to x. So we can say that dy to dx is equal to dy to du, which is this one. So minus 1 over square root of u times 12x squared minus 6x, which is the same as minus 12x squared plus 6x over square root of u. But we know that u is this, so we can write this one as 4x cubed minus 3x squared plus 1. The next question says if y is u exponent negative 3 and u is 2x minus x cubed, evaluate dy over dx at x equal to 2. We know that dy to dx is the same as dy to du times du to dx. Now y is u exponent negative 3, so dy to du is negative 3 u exponent, negative 3 minus 1 is negative 4, which is negative 3 over u exponent 4. Now we need to find dy to dx, du to dx. U is this one, so du to dx is 2 minus 3x exponent 3 minus 1 is 2. So this is du over dx. So we are going to replace these with this one and this one, so we get dy to dx is negative 3 over, but u is the same as 2x minus x cubed, so I can replace this one with 2x minus x cubed, so I'm going to write 2x minus x cubed exponent 4. This is going to be my dy over du, and then du over dx. We found that du over dx is 2 minus 3x squared. So it's going to be times 2 minus 3x squared. So this is our dy over dx, but we need to find the value at x equal to 2. So we can say dy to dx when x is equal to 2 is the same as negative 3, 2 minus 3 times 2 exponent 2 is 4, divided by 2 times 2 is 4 minus 2 exponent 3 is 8 exponent 4. Now if we evaluate this one, we get 30 over 256, which is going to be simplified to 15 over 128. The next property of derivatives is power of a function rule. What it says is that if y is a function of u, y is equal to u exponent n, and u is a function of x, then the derivative of u exponent n to x, the derivative of y with respect to x, or derivative of u exponent n to x, is the same as bring the exponent down, which is n, subtract 1 from the exponent, which becomes n minus 1, and then multiply it by derivative of the base, which is u, with respect to x. This is very similar to, if you remember, that we said that if y is x exponent n, then the derivative of y with respect to x is n exponent n minus 1. This is very similar to this one. The only difference now is that we are going to multiply it by the derivative of the base 2 with respect to x. But remember, the derivative of x with respect to x is going to give us 1. So really, this one, we are using this rule. The next question is to determine the equation of the tangent to f of x is equal to 3x times 1 minus x squared at x equal to 0.5. So to find the tangent, the equation of the tangent, I need the slope. So I need f prime. So I'm going to use f prime of x is equal to derivative of a constant. The constant, the coefficient stays the same. Now I'm going to find the derivative of x here multiplied by the bracket here. So I'm going to get derivative of x is 1, so I get 1 minus x squared plus, now I'm going to find the derivative of this part and then multiply it by 3x. So I'm going to get 3x. The derivative of 1 minus x squared is going to be times 2 times 1 minus x times the derivative of the inside the bracket, which is minus 1. I'm going to get 3 times 1 minus x squared minus times 2 is minus 2 times 3 is minus 6 x times 1 minus x. So this is our f prime. Now we have to evaluate f prime at x equal to 0.5. So I'm going to say f prime of 0.5 is 3 times 1 minus 0.5 is 0.5 squared minus 6 times 0.5 times 1 minus 0.5 is 0.5, which is going to be equal to negative 0.75. So now the equation of the line becomes, the tangent line becomes y is equal to negative 0.75 x plus b. To evaluate b, I need to substitute a point. I know that x equal to 0.5 is the x value of the point where the tangent touches the curve. So let's find the y value of this point. The y value is going to be 3 times 0.5 times 1 minus 0.5 squared. I just substitute x here to find the y, and if you simplify this one, you get 0.375. So I know the tangent has to go through the point 0.5 or 0.375. So I put this point back in this equation. I get 0.375 is equal to negative 0.75 times 0.5 plus b. If you solve this one, you get b is 0.75. So the equation of the tangent becomes negative 0.75x plus 0.75. In the next example, we have Andrew and David, which they leave at 7 a.m. from their houses. Andrew's house is 22 kilometers south of David's house. So if we assign this point to be Andrew's house and this point to be David's house, and we assume north is going up. We know that the distance is 22 kilometers between their houses. So this is 22 kilometers. Andrew runs north at 9 kilometers per hour. We know that the formula relating distance and velocity is d is equal to vt. So this means Andrew is going up at 9t, where t is in hours, while David runs west. If east is this way and west is this way, so David is going west at 7 kilometers per hour, so 7t. The question is, determine the rate of change of the distance between the two runners. At any moment, the distance between two runners is this distance. Now we are going to connect these 2 points together. We're going to get a right triangle here. This distance is going to be 22 minus 9t, because dA is 22 kilometers and Andrew runs at 9 kilometers per hour. So at any moment, the distance he travels is 9t. So if we subtract it from 22, we're going to get the distance between Andrew and David's house. Now, in this right triangle, this side is going to be square root of 7t squared, which is 49t squared, plus 22 minus 9t squared. So 22 minus 9t squared. This is the distance between Andrew and David at any time. Now we have to find the rate of change between the two runners after 1 hour. So we have to find, if this is capital D, the distance between the two runners, we have to find the derivative of this function and then evaluate it at t equal to 1. So we are going to go ahead and find the derivative of d, which is equal to 49t squared plus 22 minus 9t squared exponent 0.5. Now to find the derivative, I'm going to find d prime is, I'm going to bring the numerator down, so it's going to be 0.5 times 49t squared plus 22 minus 9t squared. Exponent 0.5 minus 1 is negative 0.5 times the derivative of inside the square, so derivative of 49t squared plus 22 minus 9t squared. Derivative of 49t squared is 2 times 49t, and the derivative of 29 minus 9t squared is 2 times 22 minus 19 times the derivative of inside the bracket. The derivative of inside the bracket is negative 9. So this is the derivative of the distance at any moment between David and Andrew. Now we have to find the value of d prime at t equal to 1. So I'm going to replace, without simplification, I just replace t with 1. So I get 49 times t squared is still 49 plus 22 minus 9 squared exponent negative 0.5 times 2 times 49, t is 1, plus 2 times 22 minus 9 is going to give us 13 times negative 9. If we evaluate this one, we get negative 4.6 kilometers per hour. This means that the distance between the two runners at t equal to 1 is equal to negative 4.6 kilometers per hour. Negative signifies that the distance between them decreases.